Hello students, welcome to Niragiri online video classes. In last class, we are discussed about the third unit, second chapter, that is special theory of relativity. It is almost completed in last class. Now, today we discuss our fourth unit, oscillations. In these oscillations, we are having some important topics. Those are simple harmonic oscillator, damped harmonic oscillator, and forced harmonic oscillator. These three oscillators are very important to the examination pattern. Today we try to know about the simple harmonic oscillations or simple harmonic oscillator. What is simple harmonic motion? What are the characteristics of simple harmonic motion? We are studied in our intermediate level. Okay, already we know that simple harmonic motion, the simple harmonic motion characteristics we are learned in intermediate level. If any motion expressed by the sine functions, if any motion expressed in sine functions or cos functions, those are called harmonic functions. If any motion expressed by the sine or cos functions, that motion we simply say that's simple harmonic. But there must be two conditions there. What are the conditions? The motion of the body acceleration always proportional to the displacement of the body and oppositely directed. These are the two necessary conditions for if any motion considered as a simple harmonic motion. Otherwise we cannot treat that simple harmonic motion. So we consider, see the here diagram, a body tied by the spring in a from rigid supporter, and we drag the body some distance and keep the body, and it makes oscillations along the horizontal axis. The type of motion is also called simple harmonic motion. So what are the conditions there? We know that the Hooke's law. What is that Hooke's law? When you apply force on the spring gets deformation, and we remove the force or we remove the weights from that spring gets its original shape and size. That property having elastic property. So Hooke's law says that elastic properties of the springs, that means stress is directly proportional to strain. So we remove the proportionality, we write the stress is equal to some constant into strain. So K is equal to stress by strain. This is the elastic limit of the given spring, what material we are using to the oscillating. That is the Hooke's law. According to Hooke's law, in this case we write the force, that is restoring force. So F is equal to minus kx. F is equal to minus k, that means k is a constant, x is a displacement. F is equal to, we know that what is the Newton's second law? F is equal to ma. F is equal to ma. What is a there? A is a acceleration. So a acceleration A is right in terms of displacement term, that value is equal to d square x by dt square. So simply we write the equating the two equation 1 and 2, m into a, that equal to minus kx. So in a replaced by the displacement terms, d square x by dt square, that equal to minus kx. Bring the minus in left side. So d square x by dt square plus k by m x is equal to 0. So this is the second order differential equation. What are the solution of this equation? Solution means when we apply the x value in this equation, finally we get the 0. That is the solution of the d square x by dt square plus omega square x is equal to equation 0 solution. So we try to substitute by knowing methods. This is the equation of simple harmonic oscillator, and it is a second order differential equation because of power is 2. Is a second order differential equation. So we trial solution method x, we let consider x is equal to c into e power alpha t. So find the dx by dt and find again d square x by dt square, and the x and dx by dt square, dx by dt and d square x by dt square value substitute in equation, d square x by dt square plus omega square x is equal to 0. So by simplifying we get the x values are both two values. We get this type of two x values. X is equal to c into e power plus I omega t, x is equal to c into e power minus I omega t. So general we take the combination of these two equations, that are x is equal to c1 into e power plus I omega t plus c2 into e power minus I omega t. This is the general solution for the simple harmonic oscillator equation. So let c1 c2 are the arbitrary constants. Find the c1 c2, substitute these equations, and finally we get the x is equal to a sine of omega t plus phi. Already I told that if any motion expressed in sine function or cos function, the displacement terms, that are the simple harmonic functions. So simple harmonic oscillator also having the simple harmonic functions. So x is equal to a sine of omega t plus is a solution of the simple harmonic oscillator equation. And also another one is also solution, that is x is equal to in place of a cos of omega t plus phi, also solution of the simple harmonic oscillator. So both terms are solution of the simple harmonic oscillators. So what are the characteristics of the physical characteristics of the simple harmonic motion? Displacement, velocity, periodic time, frequency, phase, echo. These are the simple harmonic motions characteristics. Displacement, the displacement of the any particle at any instant executing simple harmonic motion. The displacement shown by the x is equal to a sine of omega t plus phi or a cos of omega t plus phi, whatever may be, no problem. So that must be expressed in terms of these terms, only these two terms, sine or cos function. That is the displacement characteristics. What is the velocity? The velocity of the simple harmonic oscillator is equal to rate of change of displacement. So v is equal to dx by dt. So we substitute the x value is a sine of omega t plus cos phi. So differentiate cos, sine యొక్క differentiate ఏంటిది cos అవుతుంది. So substitute the cos value. The what is the periodic time? And the time taken for one complete oscillation is called periodic time. It is denoted by capital T. What are the frequency? The number of oscillation made in a 1 second is called as a frequency. The frequency indicated by n or mu or f, whatever may be. So n is equal to 1 by t, that is the reciprocal of time period. 1 by t is equal to frequency, or omega by 2 pi. So we know that omega value from simple harmonic oscillator, that is equal to root of k by m. What is the phase? The angle omega t plus phi is called phase of vibration. What is the the value of phase at t is equal to 0 because phase of okay na echo. So kabatti pi is called echo. These are the physical characteristics of simple harmonic motion and simple harmonic motion equation, and what are the general solution. This type of question very important for the important for the semester exams. Very important question. Simple harmonic motion, what are the simple harmonic oscillator, what is the simple harmonic oscillator motion equation, what is its general solution. Okay, in our next topic is we already know that a torsion pendulum in practical we had done already in our laboratory. What kind of parameters found that experiment? We find the rigidity modulus of the given wire by using torsion pendulum. The practical procedure, how to find the rigidity modulus, what are the neta value there by using torsional pendulum. This is our topic, and simple harmonic motion and its solution. and the characteristics. The examiner asked the define simple harmonic motion, derive the simple harmonic motion equation, write the it characteristics. And sometimes what are the general solution for the simple harmonic oscillator equation. So you write this type of answer on that exam. Okay.